Hello everyone. In this video, we will be designing a hook in Onshape. We'll be using a combination of surfacing techniques and a couple master modeling techniques so that we can come back to this design later and make modifications. All right, we're just going to get right into this. We're going to start by building a sketch in the front plane, which we will define as our master sketch. I'm going to need a series of lines and construction geometry to get working on this. Today, I will be using centimeters as my units. You can use whatever units you prefer and just use the same values. So we're going to start by defining the base geometry of our hook. With any sort of modeling for something like this, we want to have a clear intent on our design, and we'll do that by developing a series of sketches that we feel comfortable with. Now, actually, this line I'm going to draw as a middle and as a center point. So now what we will do is take that line, and I've got my midpoint constraint here. Midpoint constraint is going to be very useful in this situation. And then I'm going to dimension that line 70 centimeters. This top one will drive the top hitch for our hook, and this one will drive the slot that's going to be one of the main dimensions on our hook. Now, we also want to make sure that we have some angles, so I will dimension again, and I'm going to dimension in relation to that top plane. We're going to dimension that 30 degrees. We will dimension this line on the same relative angle, 120 degrees. Now, those are our core driving dimensions for our hook design, but let's build a little bit more intelligence into our hook design so that we can define it a little bit more. So we're going to use line and construction sketch again, and that line is just going to come and be parallel to this line. So if that constraint didn't auto apply for you, feel free to apply it, and we'll make it 35 centimeters. So just recapping, 70 centimeters here, 35 centimeters here. That will be how we define our arc. This will be a 24 centimeter line. That's going to be how we define our slot. Now, a few more lines we need to add here, which are going to define the tip of our hook. Make sure that that does not auto-constrain to a horizontal line, and then we're going to do a secondary line here. These are going to define the end of our hook, which is going to be the most challenging part of our surfacing problem that I'll be solving today, so we want to make sure that these are well defined. I will use the dimensioning shortcut, which is D, to dimension this line, and I will be making this line 30 centimeters today. This top line will be 25 centimeters. And we will use these again to do the final part of our surfacing problem. Now, I want to constrain the angle between the slot and that top line to be 110 degrees. I will then constrain the angle between this line and this other line here to be 95 degrees in this direction. It's maybe clearer. All right, so that should make the drawing a little bit clearer. I'm also going to hide those planes. I can press P to hide those planes. And then this line is going to take one final dimension, which is the distance from the top, right? So if you ever see a blue line, it's not fully constrained. We want to make sure that we address that constraint. So in this scenario, this is a slightly tricky constraint there. We're going to make that 5 centimeters. All right, so these are the key dimensions that we're going to be focusing on today. I'm going to try and make this drawing as clear as possible. We can just travel here and find that slot, and we're going to use this line as the key slot. We can select this dimension that the slot brought out, and we want this slot to be 25 centimeters. So that's going to be the diameter of the arcs that define the slot. We can accept that, and that's it. This is our master sketch. It looks a little bit messy right now, but don't worry. As we work through it, it's going to be clear why we've defined these dimensions, and we can add a little bit more information. Naming your sketch is always a good practice. Now that we have our master sketch, let's define the guiding curves for our loft. We're going to start a new sketch on the top plane, on the front plane, excuse me. So from this front plane, we're going to start by defining some circles. We'll dimension the circles 30 for the exterior circle, and then we'll dimension the internal circle 15. I'll move these over here for readability. Now from here, what we will build is an arc. This arc will go across, and then it will be coincident at this point. We will then use some geometry. The use tool is very, very useful in scenarios like this. We're going to have one piece of construction geometry here. That line is going to help us define the tip of our hook a little bit better. And from here, we're going to start using Bezier curves. So now we want to select the Bezier, and most of these are going to be 2-degree Beziers. They do not need to be construction geometry. We're going to just make these Beziers 2 degrees between some of the circles that we've defined and the rest of the geometry. Make sure that you do not have row constraints as you make those Beziers, or you'll have to deal with those row constraints later. Again, 2-degree Beziers. Now, there's one 3-degree Bezier here, which is just the very tip of our geometry. And now we can see that that's being closed. The next thing we want to do is we want to apply tangency across all the geometry that we've defined. So we're going to make these tangent. We're going to make these tangent. We're going to make this curve and the circle tangent. And we're going to make this curve and this line tangent. Now, to define the geometry here, which is one of the more important parts, we're going to make these tangent. We're going to make these tangent. Now we want to make those tangent to the tip as well, and that's going to mostly constrain our geometry. Now there's one more coinciding constraint that we want to apply here, which is going to be right there. So now we can start to see the shape of our hook coming together. Now, just for ease of closing the sketch as much as possible and creating some standard geometry, I'm going to give you some dimensions. So we're going to make this Bezier have a length of 11. This Bezier here, or this Bezier line, will have also a length of 11. And now we're starting to close that out. To better define this, we're actually going to add another spline control point here. So we'll make this a 3-degree Bezier. And that's going to allow us to give the hook maybe a little bit more of an aesthetic look. So we will also dimension this line 9 centimeters. Now that's relatively dimensioned. Let's also make the hook a little bit more controlled. We're going to make that 2 centimeters. Now that's really the geometry we're getting after. I'm just going to clean this drawing up for readability. This is 2 centimeters. Now let's just do a little bit more constraining to close out the sketch as much as we can. And just facilitate this process. And we will do this dimension, this line 6. All right, so that makes our sketch mostly dimensioned. We're going to make one last change here. We're going to draw a line, and this will come into play much later in the video, where we finish defining some of the other geometry. And then we're going to draft up a line there as well, which is going to help us guide some stuff later. And we can use M or trim to close out some of this geometry there. Now that we have this done, we can commit it, and our loft guides are done. All right, from here, we'll start building the profiles for the loft. To do this, I'm going to use the sketch tool. Now, some of you might not know that you can create a mate connector right off the sketch tool, but I'm going to create a mate connector right in the middle. You can see the mate connectors being generated there. Then I'm going to select this option, which allows me to rotate around an axis. I'm going to select the y-axis, which is the green mark, and that's now creating the plane that I'm looking for. So just to reinforce that, we've created a plane. You can see the boundary here in relation to that mate connector, which we've spin. We will now use a spline, and the spline is going to go 1, 2, 3 spline points, and we're going to make a second spline, 1, 2, 3 spline points. Now, we can make this go pretty quick. Once we get our shortcuts down, we're going to select that line and select vertical. We're going to select this spline line, also select vertical. We will then select this point and that point and select horizontal. So we're making that spline relatively even. Now we're going to also create a construction line here because we want to drive the middle of this point, and then we're going to create a point at the midpoint of the line. Now we select both of these points and we select vertical. We then want both of these lines to be equal. I will be moving through these a little bit faster as we go through them, but I will repeat this process one more time just slowly so we can reinforce that learning. Now we want to make that 3 centimeters. This is going to be a very important part of defining our profile. So let's do that again. We're going to select this spline line here, vertical, spline line here, vertical. We will then define a line and a construction piece of geometry that goes across. We will make a point. We can select point. We'll put that point at the midpoint of the line. We select both points. We make them vertical. We select these 2 points. We make them horizontal. We're just evening this geometry out. Now, because those lines are equal, I can select the length of any of those spline lines, 3 centimeters, and that will create that geometry. I can see that I have not made these 2 lines equal. That's an easy fix. Equal, and now we can see that this piece of geometry is fully constrained. So that's guide 1, or profile 1. Now let's create some more of the profiles. Sketch, similarly, create mate connector. We will select this line, select the mate connector options, Y, 90 degrees, flip it. We can see that that plane's in the right place. We will once again select our spline tool, and we will go, let's try that again, see if we can constrain it immediately. Spline, 1 point. So we can see that that point's not catching. That's because we don't have a line there. To make this point catch with this line, we could just use the pierce constraint. Again, we're just going to make this vertical. That's V on the keyboard. We'll make this vertical, V on the keyboard. We will make these 2 horizontal. That's H on the keyboard. We will drive a construction line between these 2. We will drive a point. Now we will drive a vertical constraint between those 2. That's V in the keyboard. And we will make these equal. Once we have defined the profile, this will be 3 centimeters. This is profile 2. Let's make one last profile, similar workflow. We will draft the sketch here. We can see that that mate connector needs to be flipped. We will do 90 degrees again along the y-axis. We now have that profile where we want it. Whoops. Now we can draft the spline, 1 point, 2 point, 3 point. This is vertical. This point and this point are horizontal. This point, whoops, this line is vertical. This line and this line are equals. This is the most tedious part of the design, but it's an important part that we need to go through just to define those profiles. Now, in terms of learning, this is going to be very useful because we can later come back to our design and decide how we want to edit this hook. So you have the freedom of really making some edits. Instead of using a midpoint, I'm just going to use the mate connector that I already established on that line. So if later you want to customize your hook, change these dimensions, this is where you should be playing around with it. Now what you'll notice is that we've created the dimensions to start lofting. From here, we're going to create our first loft. Let's rename this profile 3. From here, we're going to create our first loft. We can select loft. We want to make sure that we're on surface. We will select the first guide or profile. We want to select the second profile, the third profile, and the last profile. Now you'll see that that doesn't quite look like the hook we want it to look like, so we will turn on guides and continuity. In guides, we can start by selecting the interior arc. You'll see that that will err out the design. When I click on guides and build that guide out a little bit more. So what you'll notice is that this loft is now following that internal guide. Let's build the second guide. We'll build the guide there. Again, we got to go into the guide and build it out a little bit more. That looks pretty good. We can check the curvature by clicking here, zebra stripes, and just looking at how that curvature is being designed or built. Now that we've designed the first loft, we can build the second loft, which is a little bit more complicated. Now that we've built the first loft, let's build the second loft, which is a little bit more complicated. Once again, we will select the loft tool, surface, we will actually add that loft. It will ask us for what profiles we want to work with. And this time we will loft from the peak of our hook to the exterior face. Now, as you might notice, this is quite sharp, and that's not really the geometry that we're after. We want a cleaner piece of geometry that is more continuous. To achieve this, we're going to use a tangent direction constraint. So tangent direction, for start direction, we will select the sketch, and we will change the magnitude to 2. We can see that that's now bulging a little bit more, and then we will also change the end condition. The end condition is the second part of the loft, or the ending part of the loft. We will make that tangent. Now that's making automatically the assumption that we want a tangent to this face, and that's correct. So really, that's all we need. From here, we accept, and we've closed our hook. Now we're starting to get into the geometry that we are looking for. All right, up next, we're going to be drafting the geometry for the attachment for the hook. Again, we're going to create a plane through a mate connector. I'm just going to use this line that we defined earlier. And once again, I'm going to spin it 90 degrees along the y-axis. That's the plane that I want to work with, which is just up there. So from here, we're actually going to define the exterior geometry of just that attachment as a surface. To do so, I will be using the ellipse tool. We can build an ellipse that is horizontal, and then I'm not going to worry too much about that. So we don't really care about that dimension. We're about to delete that, and then we will make the exterior dimension 6. So deleting this dimension, we now want to make these piercing and to also make these piercing. Now we fully defined that within the plane. Secondly, I want to make a line that crosses the geometry that we just defined, the ellipse that we just defined. And lastly, we will make a piece of geometry that we will utilize later in actually cleaning up our final surface. So we want this to be vertical. Now I will define this by dimensioning. We don't really have to worry too much about these dimensions per se, but it will be a useful piece of geometry later. The final step here, just to avoid any any thoughts about going into surface modeling, is deleting that line. We can click OK, and we will now revolve a surface. So I want to revolve this surface around this axis. Now, earlier you might have been asking, why were we drawing these lines on that original sketch? And that's because we want to fundamentally loft between two geometries that are not matching, and that can be quite complicated. So today we're going to do that by using the split function. Earlier you might have been asking why we made that odd line in the sketch, and that's because we're going to use the split function on this face. We will select the face, and then we will select this line to split with. Now from here, we need to delete that surface, so we can select delete face and delete that surface. Once more, we're going to build a quick sketch on this line. We actually now have the right made connector that we can build on. I will use the geometry here and use the geometry there. I will then build a line that goes from one end to the next. And to constrain this line, I will add tangency on both ends. Those should also be coincident. Once we have this defined, we can use M or trim and just trim the two lines. We have now built the necessary geometry to loft between these two bodies. We will once again select loft, surface. We can select add or new. It will auto apply later. We will select this geometry here. And we're actually lofting to the exterior face of sketch 2. Now this loft is a little bit more complicated, so we also want to make sure that we're adding some guides and continuity. Again, that's going to break because we haven't fully defined the guide. And now we can see the guide and continuity properly applied. I will add a small tangent constraint here on the start profile condition. So we can make this match tangency. And that's just going to better the quality of our surface. We can check that surface quality once again with zebra stripes. Click OK, commit that loft. And now we're quickly going to use boundary surface to complete some of this geometry. So for using boundary surface, we will select the interior edge of that revolution that we made. And then just to make sure that this is watertight, we will close our boundary there. So this is basically a fill. And we're doing this so that we can enclose the surface. So from here, now that we've defined our surface and it is watertight, we have overbuilt a little, but we're going to fix that. So we will use enclose on the surfaces. We can select our surface, and then we want to select the front plane that we built on. So by selecting the front plane, you'll see something has just changed. That's because we fully enclosed a watertight body, and that's why we did the boundary surface. So now we've got our part defined. We can rename it. We could now name our part hook. At this point, we're pretty close to done. We just want to clean up some of our last things here. So just some housekeeping. We're going to show that sketch that we made. You were wondering why we made this face here. Well, this is sort of a cleanup phase that we're going to be using a revolve. And then we're going to be using a solid, remove, and the revolve axis is just going to be that axis from before. If we didn't fully cut that surface, that's an easy fix. We're just going here, make that 8 centimeters, and now we have fully cut the surface. Great. So we have now fixed that surface. For adding a little bit of detail to our hook, what we're going to do is drop one last sketch on that front plane, and we can show our master sketch. That's really all we need in that lofted guide sketch, and we can hide the rest of our model. So I'm going to create a construction line and a construction line. Let's say it doesn't want to find the center, so quick construction lines, and then we can start drafting some non-construction lines to add a little bit of detail to our hook. We want to make sure that those are perpendicular to one another. We can make that 15 centimeters, and then we will draw an arc that goes from here to that center line and then through that center line there. if you aren't able to find that center point, just draw another construction line like we just did, and you'll be able to do so. Now selecting the slot, we want to create 2 slots. We can make this whatever dimensions. Whoops, that's definitely the wrong dimension. Let's try that again. So we want to select slot. And here we go. This is what we're after. We can make this whatever dimension we want. And it's just going to be some detailing for the sign. So I'll go with, let's go 7.5 centimeters. We can commit that slot. Now we really don't want, we really don't want this piece of geometry here. So we're just going to make that a construction. You can also trim it out if you just want to trim it out. That's also okay. Now we're going to extrude that geometry. Let's show our hook again. We actually want to make that a remove because we're adding some detail. We're going to go through all, change the direction. Now we obviously don't want to just cut through a hook, so we're going to add a starting offset of 2.5 centimeters. Fine. Now that we're finishing with detailing, let's just apply a quick fillet, and we'll apply a fillet to these faces. If you want both faces to have a fillet in them, it'll have to be a relatively small fillet so that it doesn't error out. We'll go to 0.2. That's most of it. From here on out, we just need to mirror or part. Now, this is best practice. Be lazy when you're doing CAD. If you don't need to build things twice, just build them once. It's going to give you a better output, and it's going to take you a shorter amount of time. And you're also going to have a lot more control over your design if you use mirror at the end of your design. Now I'll Shift P to hide everything, and we can see that our hook is fully defined and ready to go. If we wanted to do some last detailing, we might want to add a little bit of detail here. So we'll just for where our contact points are going to be, and you can customize this however you want later. So we're just going to do a little offset of this geometry. Maybe we'll do 3 centimeters, and then we're going to extrude that out. We'll extrude it out around 2 centimeters, 2.5 centimeters. Looks to be a good amount, and from here we can just roll that right to the end. And now we have our hook. That's it, folks. That's how we build a quick hook in Onshape. Hopefully this tutorial was easy to follow and you were able to get the same final output. If you want to check your surface quality, you can do so with zebra stripes. Most of the surface should be relatively good quality. We have a couple areas where we could definitely improve, but you know, they say that great is the enemy of good. I left you a design that should help you get started with surfacing. If you want to customize this, there's definitely a lot of things that you can do to it, from changing these profiles that we defined, making them non-uniform, to adding some attachment points or making this profile more complicated from the get-go. There's really a lot of different approaches to a hook and how you can think about it, but hopefully this gave you a good base and got you started with some of the more advanced surfacing workflows that you can do in CAD. That was another Onshape tutorial. See you at the next one.